Energy Recovery Facility (ERF). The mass-burn ERF facility produces energy in the form of electricity, heat, or both through the combustion of residual waste. Residual waste is the mixed or unrecyclable MSW that is left after recycling. The facility treats non-recyclable waste as a resource instead of sending it to rot in the landfill. The process in the facility starts when the truck loaded with non-recyclable waste are weighed and checked in before heading inside to the tipping floor. The truck will then unload its content on the tipping floor and visually inspect for any unacceptable items which are removed for separate recycling or proper disposal. Next, another truck from the facility is used to carry the waste at the tipping floor into the waste bunker where it is thoroughly mixed by crane before being loaded into hoppers and fed to the combustion chamber. The tipping and waste storage areas are maintained under negative air pressure to contain dust and odors. Once fed into the combustion chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2000 degrees Fahrenheit for 1 to 2 hours. The process after this step will be divided into 3 paths. Firstly, the steam path, secondly, the flue gases path, and thirdly, the ash path. The steam path process starts when the waste is burned and the heat converts water in the steel tube-lined walls into steam that rises through the boiler tubes where it is superheated. The steam turns a turbine-driven generator to produce electricity or may sometimes be used directly for heating or industrial processes. The electricity produced by the turbine generator is exported to local utilities for use in homes and businesses where each ton of waste can generate 550 to 700 kilowatt per hour of electricity. Steam from the process is condensed back into water and returned to the boiler tubes, making it an efficient closed-loop system. The second path, which is the flue gases from the combustion, will pass through the semi-dry scrubber reactor to neutralize acid gases using lime and inkjet activated carbon for heavy metal control. The emission of particulate matter in the flue gases are controlled through a baghouse which employs thousands of fabric filter bags. Before flue gases are released to the environment by smokestack, the water in the wet scrubber helps to reduce temperature and remove hydrogen chloride in addition to using sodium hydroxide solution to remove sulfur dioxide. And lastly, for the ash path, after combustion, the volume of waste is reduced by 90%, leaving only fly ash and bottom ash. Fly ash collected in the air pollution control equipment is put into a silo and removed from the site in a sealed container by a licensed contractor, while the bottom ash from the incinerator will be sorted out where any remaining metal fragments such as iron and steel are recovered using a rotating drum magnet. On the other hand, non-ferrous metals like aluminium and copper are separated by an eddy current system. All the processes in the ERF will be monitored by the technicians at the monitoring room, including the facility's operation and the quality of the atmospheric discharge. A few products from this facility, such as road pavement and concrete walls, are made from the recycling of bottom ash. Bottom ash is listed as one of the waste materials suitable for recycling in road construction and aggregate replacement in concrete. Bottom ash is targeted to substitute sand or fine aggregate in road construction around the energy recovery facility, either as partial or full replacement due to its similar properties to natural sand. Bottom ash is considered to be a suitable gravel substitute as a sub-base material when used with an asphalt or concrete cover to avoid direct contact with soil and water, and it is also can provide adequate bearing capacity for lower strength application such as sub-base materials and embankment fills. Besides that, fly ash collected after the process is used in the mixture of making concrete walls around the ERF. Fly ash can be used as the prime material in many cement-based products such as poured concrete, concrete block, and brick. Fly ash can be a cost-effective substitute for Portland cement in many markets. Materials discarded every day should be utilized to their fullest potential to preserve the world's valuable resources and generate clean energy for our communities.